Hey scholars, I hope y'all are doing great today. For this lesson, we are going to talk about how to graph sine and cosine functions. So we're going to first talk about how to determine the amplitude, period, and midline of an equation of a sine or cosine function, and then we're going to graph them. So make sure you're paying close attention and taking good notes. Let's get going. Alright, so before we actually graph sine and cosine functions, we are going to talk about their transformations, how to look at the equation and figure out what the amplitude is, the period, and the midline. So for graphs of y equals a times sine of b times x plus c, so here's one equation. So this is the general form for a sine function. Or y equals a times cosine of b times x plus c, so here's the cosine function, and x is in radians, so pi over 2 pi, whatever. Here are some formulas for the amplitude, period, and midline. Okay, so for the amplitude, you just take the absolute value of a. Okay, for period, you're going to take 2 pi and then divide it by the absolute value of b, and the midline is going to be y equals c. Okay, so get those formulas copied down. Okay, make sure you know those, and then let's look at this function here. Okay. So here we got an example. Y equals 4 times sine of 3 times x plus 2. So the amplitude, we're taking the absolute value of a, right? So the absolute value of a, this would be the amplitude. Well, a is 4, isn't it? A is 4. So we're taking the absolute value of 4, which is just still going to be 4, right? If you take the absolute value of a number, if it's positive, it stays positive. If it's negative, it becomes positive, right? So if a was negative 4, the absolute value would still be 4. The amplitude would still be 4. All right, so for period, well, b, I guess I can put that there. B is 3, okay? So we're going to say 2 pi divided by the absolute value of 3. Well, absolute value of 3 is just 3. So the period of the function would just be 2 pi over 3. So that cycle, the period is going to repeat every 2 pi over 3 radians that you would see on the x-axis. And then the midline here. So here is c. The value of c is 2. So the midline is just going to be y equals 2. Y equals c. Y equals 2. That's the midline. Okay? So that's how we determine the period, amplitude, and midline. So as we're talking about these transformations, which depend on the value of a, b, or c, if you change the amplitude, which is a, right? If you change the value of a, that's going to make it a vertical stretch or a vertical compression. It's going to either stretch it or compress it inward. Okay, it's going to stretch that wave up or compress it inward. All right, so for it to be a vertical stretch, a is going to be greater than 1. We'll say the absolute value of a is going to be greater than 1. For a compression, the absolute value of a is going to be in between 0 and 1. So it's going to be greater than 0, less than 1. So like a fraction or a decimal, okay? That would make it a compression. A change in the period is going to indicate a horizontal stretch or compression. Now, remember, we're going to look at the absolute value of b to determine a stretch or compression. In fact, we're going to say 2 pi, right, divided by the absolute value of b. Now, if we want that to be stretched, we're going to divide 2 pi by a fraction, okay? So for it to be stretched, b is going to be less than 1 and greater than 0. Now here's the thing. That might be confusing. It kind of seems backwards from the vertical stretch, and it is. If you take 2 pi and divide it by, I don't know, let's say 0.5, 1/2, right? 2 pi divided by 1/2 is going to be 4 pi. So that's going to make the period longer, okay? That's going to stretch out the length of the period. Now, if you had 2 pi divided by 2, which is a number that is greater than 1, the period of a parent function is 2 pi, right? And if you divide that by a number like 2, a number that's greater than 1, that's going to make the length of the period smaller. So it's going to compress it horizontally. Okay, so now if a is negative, then the function is going to reflect across the x-axis. So it would just flip across the x-axis if a is negative. Okay? And then a change in the midline is just going to shift it up. If c is a positive number, it's going to come up, but if the value of c is a negative number, it's going to go down. Okay? So, for example here, we have, this is going to be a cosine function because it's symmetrical around the y-axis. So I'm going to say this is y equals, let's figure out what the value of a is. Well, the amplitude is 2, right? So 2 times cosine, like I said, it's a cosine function, times, now the period is 4, right? Well, 2 pi divided by what equals 4? And I really should have put that be an absolute value, right? Anyway, 2 pi divided by what is 4? Well, I can do a quick swap here. Check this out. And this is a little trick for solving equations where the variable is in the denominator. You can do a quick swap. I'm going to get 2 pi over 4 equals b, absolute value of b. And 2 pi divided by 4, well, that's going to simplify to 1/2 pi, or you could say pi over 2 equals b. Okay? So what we're going to have is b is pi over 2x. Okay? So b is pi over 2x plus c. Well, what is the midline? It's 3. Okay? So there's the equation of that graph. And if that confused you at all, maybe rewatch that part for a second. But if you're feeling a little overwhelmed, just stick with it. We're about to graph some functions. All right, so let's use the unit circle to help us graph y equals sine of x. Now, something that's going to be helpful for us is to know that b is 1 here, as I already have written on here. So we're just going to say 2 pi over b, the absolute value of 1 is just going to be 1. That's going to be 2 pi, and that's the period, right? So you know that the sine function is going to start at the origin, or it's going to have a point at the origin. We'll start with the period here at the origin. So it has a point here. When the x value, when the radians are 0, looking at the unit circle, right? The y value, the sine value is going to be 0. So you have a point 0, 0. 0 radians, sine value is 0. All right, so then the period is going to be 2 pi, right? So starting at 0, going all the way over to 2 pi, we're going to end up in the same spot, aren't we? You're going to have a point right in the middle. Remember, for a full period, it's going to pass through the x-axis 2 times. So right in the middle of 0 and 2 pi, you're going to have pi. So you can put a point here. Now, this is just a shortcut. If you want to look at how the unit circle pertains to this, rewatch that video that you watched earlier this week. All right. So now you're going to have a maximum at pi over 2. That's because when you have pi over 2 radians on the unit circle, the y value, the sine value, is 1. So we're going to have right here, and then at 3 pi over 2 radians on the unit circle, the y value is negative 1. So we're going to have the y value on this graph right here at negative 1. So then here's one full period. All right, so and then this is going to repeat itself on the other side, kind of look like a mirror reflection here. Then you're going to have at pi, negative pi over 2, you're going to have a minimum here, and then it's going to come back up at negative pi, just like it went through here at pi. And then we're going to have a maximum, negative 3 pi over 2, and then at negative 2 pi, the period is going to end, right? So there we go. Here's the graph of the parent function of y equals sine x, the parent function of the sine family. All right, so now check this out. We're going to graph another function, a transformation of the sine function. What we're going to do is identify the amplitude, period, and midline of g of x equals 3 times sine of 2 times x. So here was f of x, and that function was sine of x, the parent function. Let me use blue to graph g of x equals 3 times sine of 2 times x. So the amplitude, what's the amplitude? Well, here's a, so it's the absolute value of a, absolute value of 3. Well, the amplitude is just going to be 3. The period is going to be 2 pi over the absolute value of b. Well, what is b? It's 2. So the absolute value of 2 is just 2. So 2 pi over 2, well, that's going to equal, 2's will cancel out, right? So that'll be pi. So the period is going to be pi. So the period for f of x, sine of x, the period was 2 pi, right? For it to make one complete cycle. For this function, one complete cycle is going to happen over the course of pi radians. So this is actually going to be stretched, it's actually going to be compressed horizontally, okay? Like it's going to be pushed in, all right? So the period is going to be pi. All right, so what's the midline going to be? Well, the midline, we have 3 times sine of 2 times x plus 0, right? The value of c is 0, so y equals 0. That's going to be the midline. And that's actually the same for the parent function as well. We had sine of x plus 0 because we don't see a value of c here, so we know it's going to be 0. So the midline is actually, for both these functions, going to be the x-axis, y is 0. All right, so now let's compare this to the sine function. So the sine function is going to stretch vertically because the amplitude is going to be 3. It's changing from an amplitude of 1 to 3. So I'm going to go right here. That would be 2. This is going to be 3. So, and then it'll go down to negative 3 as well. So I'll just make note of that here. All right, so in the period, it's going to, like we said, it's going to kind of compress inward, right? So it's a sine function, and it has not been shifted up or down, which if it was, the midline would be changed, right? So it's going to have a point right here at the origin, just like the parent function did. But here, for the parent function, half of the period was at pi, and then the second half of the period ended at 2 pi. Full period is 2 pi, right? But we're going to have a full period at pi. So I'm going from 0 to pi. This is going to be the whole period here. We're going to have a maximum and minimum in between these 2 points. Now, what is in between 0 and pi? What's halfway there? It's pi divided by 2. Divide something by 2, you cut it in half, right? So it's going to pass through the x-axis at pi over 2. Now all we have to do is find the maximum value and the minimum value. Well, in between 0 and pi over 2, we're going to have a maximum value, okay? So that's going to be at 3, right? Because the amplitude is at 3. So there's the maximum value. Now, in between pi over 2 and pi, it's got to have a minimum value, right? So then that's going to be at negative 3. So over the course of one period, you've got to have a maximum and minimum, and it's in the middle, in between there, it's going to pass through the x-axis, right? So we're going to start on the x-axis, hit the maximum, go through the x-axis again, hit the minimum, and boom. There we go. And then that's going to repeat. Okay, so we would have another maximum here. That cycle's just going to repeat. We're going up to 3 again, back through the x-axis, minimum down here, and boom. There we go. So same on this side. We're going to have a minimum negative 3. See, it's going downward, right? Down to negative 3. I'm going to come back up through here at negative pi over 2. Maximum at y equals 3. And then, boom, this is going to keep repeating. So I'm going to put that point there. And then we'll have maximum right here. Alright. And then back down. Alright. So there we go. That is a transformation of the sine function. Alright, so hang in there. We're going to do a transformation of the cosine parent function. Alright, now let's graph y equals cosine of x, and then we will graph a transformation of that. Remember, y equals cosine of x is the parent function of the cosine family. So I'm going to say that this is 1 on the y-axis. Remember, we're going to have a point here, a maximum point at 1. Remember, at 0 radians on the unit circle, cosine is the x value, right, of that coordinate. And so the x value at 0 radians in the unit circle is 1. So we'll put a point there. All right, so then at pi over 2 on the unit circle, the x value is 0. The cosine value is 0. And then at pi, you're going to have a minimum here. All right, and then because the cosine value is -1. The x value on the unit circle at pi radians is -1. All right, then at 3 pi over 2, the x value is 0, the cosine value is 0. And then at 2 pi, you're going to have another maximum. You're back where you started, right? 2 pi radians is the same place as 0 radians. So you're going to have another maximum here. All right, so you can connect those dots. This will be one cycle, one period. And then we will graph these points that match on the other side. So boom, and then boom. Then -2 pi, we have 1 here. All right, so and if you need a little more in-depth understanding of how to graph that, refer to the Ed puzzle. You can find it on Ed puzzle that I assigned to you last week. Okay, so that's what the cosine parent function is going to look like. Let me make that look just a little bit neater there. Oh well, might not be much different, but here we go. All right, so now we're going to graph a transformation of that. We're going to graph g of x equals 2 times the cosine of 1/2 times x plus 1. Okay, we're going to say that this is f of x. I think it said y on the other side, but we'll say this is f of x equals cosine of x. And then we're going to graph g of x, and I'm going to graph that in blue. Okay, so we want to identify the amplitude, period, and midline of g of x first. Okay, so let's look at this. I can easily identify the midline. The midline is going to be y equals 1. Okay, for the parent function, it was y equals 0 because it was cosine of x plus 0, right? So that was the midline, the x-axis. But here, the midline, I'm going to put a dashed line. The midline is y equals 1. So I'm drawing a dashed line through y equals 1. All right, and then the amplitude. Well, and one was C, right? So the amplitude is A. The absolute value of A, well, A is 2, so the absolute value of 2, the amplitude is going to be 2. Now the period. For the period, we're going to say 2 pi divided by the absolute value of B. Well, B is 1/2, right? The absolute value of 1/2 is just 1/2. So I'm going to say 2 divided by 1/2. Well, if you say 2 divided by 1/2, that's going to give you 4. 4 pi would be the period, okay? 4 pi. So here's the deal. From -2 pi to 2 pi, that is a total distance of 4 pi, okay? So this whole graph is going to be one period. If you look at the cosine here, we actually had 2 full periods, okay? You can see those. Here's one period, here's the other period. And the period of that function is 2 pi. But when we're doubling that, it's going to take up the whole graph. We're doubling it to 4 pi. All right, so here's the deal. I'm going to look at the midline. And from the midline, I'm going to see that the amplitude, we're going up 2. The distance from the midline will be 2 units. So I'm going to put a point there, okay? So it's been shifted up 1, and then it's been stretched. So the amplitude, the distance from the midline is 2 units, okay? So now we are stretching this out. Like I said, the period is doubling, right? So we're going to stretch it out to be twice as long, okay? So I'm going to look at these units on the parent function, and if this is pi over 2, I'm going to double that, okay? So I'm going to say pi over 2 times 2, that's going to give me pi. But since on the parent function, this was on the x-axis, which is the midline. The x-axis was the midline here. I got to plot this point on the midline. So it's going to be on the midline, and the distance on the x-axis is going to double. I'm going to put a point on the midline at pi. Okay? All right. Just follow along with me here. If it's confusing, it's okay, you can rewatch it. So then we're going to have a minimum value, okay? So the minimum is at pi, right? Now, remember I'm doubling the period, right? So I'm going to say pi times 2. This point's going to be 2 pi, okay? The x value is going to be 2 pi. Now, we were 1 unit away from the midline on the parent function. So we're at 2 pi, we're going to be 2 units away. The amplitude is 2, right? 2 units away from the midline. So there's going to be this point, okay? So this point is going to match up with that point. All right, I've transformed this point, and this blue point is a transformed point of that. Now the rest of this graph's not going to fit on this graph. Right here, that part's not going to fit on the graph. I've already made it to 2 pi. Okay? So just going to connect those dots there. Now, I'm going to find the corresponding part here. So if this is pi here, this is going to help if we just think about it as being flipped over the y-axis, okay? So I got to come back down to negative pi right here. I'm going to connect that dot. And then at negative 2 pi, we're going to have another minimum. So here's the deal. One cycle, one period, right, was 4 pi units. Well, from minimum to minimum, that was 4 pi, okay? And you can see that the amplitude, the distance from the midline to the minimum points and the maximum points is 2. That's the amplitude, okay? 2 units there. All right, so now, I know some of that might have been a little bit tricky. Highly suggest you rewatch it, okay? This is going to take a lot of practice, but stick with it, you'll be just fine. But for now, just pat yourself on the back. You just graphed a transformation of a cosine function. So I hope that video was helpful for you. I know it was probably pretty confusing at times and a little bit tricky, but we're going to get a lot of practice in class, and just make sure that you're doing your best to understand. Maybe rewatch parts of this video. You're going to have to get this down, okay? But you can do it. Make sure you put in the work. Good work today. Thank you, Collegiate Scholars.